Okay, so we are now recording, and as I do with at the start, I'm just going to ask everybody if it's okay to be recording, you guys.
Yeah, I'm cool with it.
Yeah, it's all good.
Everything you say can and will be used against. No, I'm kidding. Okay, perfect. So where did we leave off? Let's just go over it again.
I think it was we stopped at making the deadband.
Yeah, so we actually after you wait, were you there to the very end?
No, I had to
I
leave
think.
at like
Yeah.
9:30.
Yeah. So basically we ended up finishing. So just to go back over, just to recap what we did last time, is there was a real world problem that Diego mentioned, or that Gabe mentioned. So Diego is the driver, and he was doing driver practice, and he was noticing that that the driving was a little jerky, right, or something like that.
Yeah.
And so what we did yesterday was we basically wanted to create a way for Diego to be able to adjust all of the different types of filters that can help with this jerkiness, but we don't want to hard code in like certain values. We want him to be able to, without having to re-push the code, change a value, and in real time, the robot then have a different behavior. So we called this a joystick modifier. Just to recap, what we did is at the start, we wrote out what we want to do. Okay, because at the end of the day, we're not writing code just to write code. We want to solve a certain problem. So we want to create a custom class which extends a joystick's axis reading and applies a smoothing function to it. Okay, so we went over a few different methods that we can apply to the joystick to smooth this behavior out. The first is a deadband. So, when, within the little radius around, the joystick's neutral position, that should be registered as 0. There's something called a slew rate control, which is basically limiting, hold on. Oh, yeah. Which is basically limiting the, hello, this is Jamie, right?
Yeah, it's me.
Perfect.
Sorry to fail to join.
It's all good. We just started. So we're going over what we did yesterday, and then that's going to segue into the next step. So basically, Diego has been doing driver practice, and he noticed that it was kind of like shaky, or it was like jittery or whatever. So what we're doing here, what we did yesterday, is we wrote out like, how do we solve Diego's problem? And so there's a few different, so there's something called a deadband, which again is within the, like the joystick's neutral position should, return, it's not going to be exactly 0, but it's like 0.002 or whatever. So that'll fix kind of the robot like moving if you're not touching the controller. The second, which now we're getting back into it, is the slew rate limiter, which is basically it's controlling how fast the joystick can change its value. So if you go from 0 to 100 like right away, like that might be too fast. It's getting from 0 to 100 too fast. So there's a slew rate. And then there's something called a quadratic filter, which also kind of like helps to change the jitteriness. Okay. So what we did here was we created this custom class to satisfy the above. And we started out very simply. As you see this right over here, like all of this code, it looks like, how did we get to it? But I have yet to put the video online. But as Raylia saw as we developed, and as if you watched that video, it was we started very simply, right? Raylia?
Yeah.
We started out very simple,
Yes.
right? And then we built upon that solution until we got this. So that's the first thing that we did. The second thing that, okay, so that was at the end of yesterday. And then Gabe mentioned in the, okay, for a while, join when you can. If you want, be a fun, all good. Something that Gabe mentioned, snap to, okay. Diego, something that would be very, very nice to do is, let's say your robot, okay, this is a sneak peek of what we're going to be working on today. New path. Okay, I don't know why it's not showing the whole screen. Oh, okay. So, yes, pretend, what if your robot is like, let's say here, okay? Or let's say it's over here. And you're like driving your, see the robot here is facing exactly kind of like straight. Actually, if we go to the arena, hold on. FRC 2024 manual. Okay. So if we go to, let's say, the arena, okay? I forget all the names of these things. But let's say your robot is over here and you want to, can you score it over here? This is where you score, right?
Yeah, that's where we score. It's the speaker.
The speaker. So like when you're at the speaker, you kind of want to be like exactly facing the speaker. But imagine Diego like having to like align it so it's like he's like perfectly facing the speaker. Like that's, you know, whereas what you can do is you can have one of these buttons, like let's say the Y button makes you face directly towards the speaker. Okay. And then what is this called? The amp? No.
Yeah.
Yeah, it's the amp.
This is the amp. So the amp is at a 90-degree angle. So what you can do is, if you can make like the Y, X, A, and B button such that if you click the Y button, you're like locked into a certain angle. So it's like facing the speaker the entire time, and you can still drive around, but you're driving around at that angle, if that makes sense. And then if you press the X button, then it makes your robot always facing 90 degrees, which is like towards the amp. And then A and B, also same kind of thing, but in reverse. So do you see that?
Yeah.
Okay. So, so Gabe mentioned that yesterday, and I kind of just did it. So there is, I mean, it's also kind of built in, where it's quite easy to do, where there's this thing called field-centric facing angle, where basically you can be driving, you know, around the field, but the direction is locked to 180 degrees or 270 or 90 or 0 or something like that. Does that make sense?
Probably.
Yeah.
So what I'm gonna do, I really wish I had an Xbox controller, but I'm gonna be driving on my keyboard and you'll see all of this, okay? This comes with a simulator and it's really cool. It's kind of fun. But again, don't judge my driving because, okay. Whoa. Okay, so do you see this? See, I can move around. This is like the actual code running on my computer, which is causing this to drive. And then I think if I see that. So this is the swerve drive working. Whoa. Oh, okay. So if I press one of the buttons, do you see this? Now I can drive around the field, but it's locked. It's always facing down. Done. Now if I pressed another button, you see now it's facing the other way?
Yeah.
And if I press another button, it faces this way. Fine. So, and these are these are buttons that now Diego can use, and this solves a very big problem for him. Hey, Truman.
Hey, how's it going, guys?
So just one more time, what I'm showing here is the actual robot code working in simulation. So I can like drive it around and whatever. And so we now have buttons which lock you onto a certain angle. So it's like super easy to, you know, align yourself to a target and still move around. Okay, so that's what we have so far. Okay. The next thing is, okay, so that's all good. Let's actually take a quick detour and let's kind of apply the same kind of, what's it called? Let's have a very simple exercise, which is kind of in line with what Brandon was teaching today. It's kind of like back to basics, kind of. And let's actually apply it to this. Okay, so we're actually going to be cleaning this code up. Okay, and as we clean this code up, and it'll take like 5-10 minutes, we will see how to like do more programmy kind of things. Okay, so do you see this code right here?
Yeah.
And do you see this code right here?
Yeah.
It looks very similar, right?
Right.
What's the difference between this piece of code and this piece of code?
The
Actually,
button.
all four of these.
button
Huh?
and the degree.
The button and the degree. Exactly. So we have an A button right here, and that's mapping to 180. We have the B button, which is mapping to 270. We have the X mapping to 90, and we have the Y mapping to 0. Okay. So we can kind of like get rid of all these three and kind of have like some sort of loop which will clean this up. Okay. So how do we do that? What are some of your thoughts on how we can loop over, how we can do some sort of looping and getting rid of these three? I don't know if that makes sense.
Maybe we can do like a for loop. I don't know if that'll work for each button, A, B, X, and Y. You would like have like plus 90 or something.
Okay, that's a great idea. For each button, add 90 degrees, something like that.
Yeah.
Yeah, so that's definitely something we can do, and we'll actually do that. There's also another way of doing it, which is basically like your idea is have as the first one Y because it starts at 0, and then X, and then you add 90 degrees every time. Is that what you're thinking?
Yeah.
Okay, so let's do that. Does that make sense, everybody else?
Kinda, yeah.
Okay, so let's work through this, okay? So what we want to do here is, and again, I don't actually know Java syntax so well, so this will be learning opportunity for all of us, okay? So what we want to do is whenever you have a grouping of elements of, of numbers, of, Booleans, and you want to loop through each of them, you put that into what's called an array, okay? Or sometimes they call it a list. And the idea of an array is it's a list of variables of the same type. Okay, so create an array of triggers. Let's call it. Let's see. Well, it's kind of doing the logic for it, or doing the thing for us. So how do you actually create an array? So Java
You
array.
do curly brackets, right?
Let's see. I actually, so
You would do
like that.
the brackets, yeah.
Okay, so basically you see this A, okay, so this is joystick.a, and this is joystick.b. But both of these are like, they're different, like buttons, but they're the same trigger. So these are all triggers. So joystick.a is a trigger, joystick.b is a trigger. Okay, so the array that we're going to be setting up is an array of triggers. Okay, and we can just do this. Okay, we can do something like that. Okay, so here are all of my triggers. Okay, does this make sense?
Yeah.
So this basically, if I want to like what's it called, access the A trigger, what I can do is do triggers, and then this bracket syntax is like get me the blank element in the array. Actually, it doesn't like that. Is it dot get? No. Wait, why? Yeah, okay, fine. That works. Okay, so this is how to access the first element in the array. You'll see that I have 0 here. In most programming languages, like counting starts at 0. So for accessing the first element, it's actually 0. For accessing the B button, it's 1. Okay. Does that make sense?
Yeah.
Okay.
Yeah.
And now we need to order these, so Y is 0. X is 90. So we have to orient these as Y, X, A, B. Okay. So now basically, somehow we have to loop through these. Hey, Evie, do you want to sleep in my bed? Okay. Loop through these triggers and add 90 degrees to each one. So how am I going to do that? So we're going to do what Raylia said, which is, that's not right. Let's do not that syntax. Okay. Do, do, do. Okay, something like this. So what this syntax is, this is a for loop, okay? And right here, it's taking 3, you see this semicolon?
Yeah.
There's 2 semicolons, which means it breaks it up into 3 different parts. The first part, the second part, and the third part. The first part is kind of like initializing, usually it's about initializing a counter or a variable. So in this case, it's I equals 0, okay? And so what this I is gonna be is, or maybe I'm gonna name this position. And I'll show you why I'm naming it position. Okay, so this position here is gonna represent the position like in the array. So for example, is this, do you guys know about this, or is it like, is this review or is it not review?
It's mostly review. Yeah.
Arrays are review, yeah.
Okay, so I can go on more. I can
Yeah.
go a little faster.
Yeah.
Okay. So please just always, you can always tell me if it's, so basically what I have to do is, so here I'm grabbing the relevant trigger, okay? And all I have to do is call trigger dot, and then just yank all of this out. Oh. Okay. And in this way, what just happened? Okay. So what I've done here is now I'm just, for every one of these these buttons, I'm attaching this trigger. So that's the first part. Now I've abstracted the first part, which is the trigger. Now the second thing is I have to do something with this, okay? So what should I put inside of here in order to get this functional, so that for Y it's 0, for X it's 90, 180, 270.
We can make another variable, like a degree variable.
Okay, so how would I compute the the correct degree variable.
You could do I times 90, right?
Yep. In this case, it's position times 90.
Oh, my bad.
Yeah. Wait.
Wouldn't it be plus 90?
Oh, there was that like local variable position. Final end. Okay, I don't know why I have to do this final, but okay, whatever. Yeah, so basically, I'm taking this position, which is a counter, 0, 1, 2, 3, and 0 times what equals 0? Well, anything. But 0 times what equals 90? 90. Or 1 times 90 equals 90. 2 times 90 is 180.
Oh,
So
that's what you mean. Okay.
yeah. And I'm gonna rename this to I, just because it's convention. But I don't know why I have to do this. Somebody needs to join the call. Who is that? Max. Okay. So yeah, this seems to work. So now I can remove all of this code. So you see how using a for loop has actually helped us clean the code up a little bit.
Yeah.
Cool.
Made it much simpler.
Yeah, also much simpler. So these are not just triggers. These are, what's a more descriptive name for A, B, X, and Y? They are the
Button.
orientation snap triggers. I don't know. Like, what are they functionally doing? They're kind of like snapping the robot to different orientations.
Locking to
Yeah.
direction.
Direction lock triggers. I like it. Here, cardinal direction lock triggers. Cardinal just means like north, east, west, south. That's what 0, 90, 180, 270 is. And yeah, so I like it. And now if we just go to simulate robot code. Okay. Tally up. I'm just going to check that it still works. Yep, it all works. So we didn't mess anything up and we clean the code up. So what I'm gonna do now is I'm just going to commit this code. So nice. So cleaned up hardened snap command triggers. Nice. Okay. So that was kind of a side thing, but I think that was a good little experiment. Okay. Now the question is, we want to get Auton working, and for that, I mean, I've actually never done it before, but I haven't done most of this before. So we're going to explore this together. So, oh no. Hold on. So, does anybody have any insight into what does it mean for autonomous driving? What does that even mean? Like, can we bring some definition to it? Like, what does it mean
robots running on like pre-made code?
Okay. So let's start there. Yeah, that's good. I mean, right now we're doing everything all in the robot container, which we'll have to. Okay, what does Auton path following mean? So runs, drives on what?
Pre-written code.
Okay, so what does that mean? Drives on pre-written code. Like all of this pre-written. Like I wrote it before, you know. So
Yeah.
so let's expand upon this because you're on the right track.
So you're gonna need a different trigger then.
Okay. So continue.
So it could be like when enabled or when the robot starts, it like executes the command.
Good idea. So good. So you brought up a few very interesting things, which are we are using command-based programming, right, for everything. In teleop, commands are scheduled to run when a certain trigger is created or something like that, or is triggered. So for example, here, so actually a more general question is, how are commands scheduled run? One is when a trigger tells the scheduler to run a command. So for example, in this example right here, which we just did, is we are running this field-centric facing angle command. Right? If you hover over this, this is a command. We are running this command when the trigger, when the trigger triggers, when you press a button, what it does is it triggers a command to be scheduled. Does that make sense?
Yeah.
Also with this, right? When the left bumper is pressed, do this. This right here is a command. So you see how if you, like in teleop, when a trigger tells us, when a trigger is fired, it tells the scheduler to run a command. Is that clear?
Yeah.
So also in teleop, see this right here? This right here is just like normal driving around the field. You're not pressing a button. You're not triggering this, drive swerve to run. And that's because you can have a certain subsystem have a default command. So number 2 is default command is given to a subsystem here. A subsystem can be given a default command. This is scheduled when no other commands are using the subsystem. Are these two clear, or are there questions here?
Yeah, that's good.
I get
Makes
it.
sense. Okay. So this is and both of these are the only ways that commands can be triggered in teleop mode. So when it comes to, now it comes to, now we're going back to Auton path following. Okay. So there is going to be a command, right? Because everything is a command called Auton path following, or follow path, follow drive path. Okay. So there's going to be a command called follow drive path. What do you think this command needs in order to follow the drive path, or to actually like do it?
It needs a trigger.
I think it's going to be kind of like the trigger or whatever. Maybe it's actually just a default command, but when the drive, when it's in Auton. So I don't think there's going to be a trigger that triggers this event. I think like when it's in Auton mode and Auton mode starts, it'll like just, maybe this is like, you know, get default Auton command or something like that. So there's no trigger, but what does this need in order to run successfully?
A path to follow.
Yeah. A predetermined path to follow. So it'll need a predetermined path to follow. So yeah, exactly correct. So what we're gonna do is, what's the next step? So, okay. So now we're gonna start getting into Path Planner, okay? The FRC, you know, like community has created graphical interfaces in order to generate these paths, okay? And so let's actually just go through it a little bit. Okay, so let's say our robot is starting over here, you know, at the beginning of the match. And let's say we want to, this is a node on the floor, or
Yeah.
do you get a node like,
Yeah, you
do you
can
get
preload it. Yeah.
preload? Okay, so let's say, and you shoot in here if you're the blue team.
Yeah.
Yeah. Okay.
Yeah.
So let's say our Auton path is like this, where you're like facing this way, right? And then you rotate. I've never done this before. Add new waypoint after. What's this rotation target thing? I don't actually know how this works. Let's do something, let's keep it simple for now, okay? So let's get rid of this. Let's just say we want to do a path like this, okay? So let's look at the different things we have to, you know, we're allowed to set. So we can add different states in which we want the robot to be in. So we want the robot to be here and also here. So there's an X position, a Y position, a heading, right? This is the angle. Then what is this next control length? Is that this? That's this, okay? And so you can just add a bunch of waypoints. The next thing is global constraints. This is how, because right, a path is just a geometric kind of curve. I think that these are called Bezier curves, which they're using here. But these are nothing more than curves, right? Does that make sense? Like this right here, this path is just a curve. But there's a difference between a path and a trajectory. A path is like literally just the geometric curve. But what a trajectory is a series of it's like telling the robot how fast it can go, how long it should take for the robot to go from this position to this position, right? Because like, remember, at the end of the day, the code is running every 20 milliseconds. And what we need to know as part of the code is in 20 milliseconds, where should I be? And in order to know that, in order to set that, we can say what the max velocity of the robot is. And remember, this is something that you were tuning.
Yeah.
So this max velocity is, you're basically setting what the max velocity of your robot can be, so that when it generates the actual path, it takes the path and it slices it up into little, sections. Every 20 milliseconds, there's a new section. And that's determined by this value. Okay? So you can set these. Goal, end state. Okay. So what this is doing here is it's saying at the ending position, should I be stopped or should I be like end with a certain velocity, right? If you're stopped, then the path should look like this. But if your ending velocity is 4, then I guess I'm not sure. It's like, is there a difference? Wait, let's see. Okay, I mean, there should be a difference of some sort. What's rotation target? I'm not exactly sure what rotation target is and why we have so many here. Let's see what happens if we get rid of all of them. Add a new rotation. Oh, maybe when I clicked this, I see. $180. What does that do? Oh, interesting. You see what that did? Something. If I get rid of this, the path looks like that. Okay, I mean, because what I was trying to get at is when you're over here and you want to, let's say, shoot the note, you don't actually want to move, but you want to just turn in place, right? That turning in place like might be this rotation target. Does that make sense?
Yeah.
Yeah.
This event markers is actually very interesting because Auton mode is not just about driving around the field. It's at this position here. I think at that position here, you want to, let's say, shoot the target or shoot the note. right? And then maybe, let's say, maybe when you're over here, you want to start intaking, right? And that's like now, like the shoot the note is going to need the shooter, and then the intake the note is the conveyor, right? So these event markers are there to you see this right here? So along the path, what you can do is you can put like little milestones, or I don't know, markers. And then at this marker, you can say, okay, it's going to be kind of like a group of other commands that should be scheduled. So let's say, I'm not going to go too much, but like, let's say over here. So over here, you want to do something, and over here, you want to do something else. So this event marker inside of the trajectory will also be an event marker such that your code can listen to this event marker. You can name this, like, let's say, start intake, or, shoot, launch note. So maybe this will be like launch note, okay? Okay, and then your code will say, oh, launch, I see the launch note event marker. That means I have to schedule this command to run. Does that make sense?
Yeah.
Okay, so that's what these event markers are for. Not sure exactly what a constraint zone is. Okay. I'm not sure. Oh, not really sure. Okay, fine. So there's constraint zone, blah, blah, blah. And then, okay. And so basically you configure the path with all of the different settings in here. Okay. I'm gonna, collapse it. And now let's see okay, so what do we do with that, right? So once we've set this path, let's say we call this Auton 1, okay? Now, somehow, we have to get that into our program, so our program knows about it. Let's see. I don't know how to do that. So what we're going to do is go to FRC Path Planner and look at the documentation. Okay. Okay, let's look. Here's the path planner. Let's read the documentation. Each path is made with Bezier curves, yeah. Holonomic mode is supported, which is swerve. Real-time path preview, allow placing event markers along the path, which can be used to trigger other code while path following. Build modular Auton routines using other paths, interesting. Automatic saving and file management. Robot side vendor library for path generation, custom path following commands, controllers. Full autonomous command generation. Real-time path, okay. Hot reload, nice. Okay. So here's path planner. Okie dokie. Rough and okay, so actually Aaron has done this before, so so here's the GUI. Project browser, folders, manage, okay. So this is something that we can, okay, before delving too much into it, in too much deeper into this, there's actually also another similar tool that came out this year called FRC Choreo. Let's just look at it, okay? Let's look at how they do it, okay? And also when this project first started, or people like got together and wanted to work on this new project, I was on the Discord, and they have a Discord channel. So I've kind of been like following it a little bit, but not so much. But I know that it exists, which is nice. And now let's look at Choreo, okay? And then from there, we'll see like what makes the most sense for us to use. Okay. Choreo is a tool for transforming 2D paths from rough sketches into optimal trajectories. Let's see. Advantages. Okay. Okay. Maybe we can download it and see. Let's see. Choreo. I think, check out the docs. Okay. He said, finds math on an optimal trajectory, passes through your waypoint.
I'm gonna have to go now. Bye-bye.
Okay. Thanks for coming. Okay. So let's look at this. This looks interesting. Waypoints are an ordered position that you'd like to hit on your path. There are multiple types of waypoints based on what you'd like to constrain in your path. To add a waypoint, select the type of waypoint from the waypoint's nav bar. Okay. Then click on the field where you want it. Your waypoints will show up in the sidebar. Yellow dot represents the currently selected waypoint. Green, okay, so green is starting, red is ending. Okay. So pose waypoint. This seems to be kind of interesting. So there's a pose waypoint. What does pose mean? Pose is a combination of your X, your Y, and your theta. All those together refer to your pose. So it's like where you are on the field. So on the X direction and the Y, that locks you into a point, but you can still be at any angle. So this locks you into that pose. Does that make sense? People can speak up, so I'm not just like talking to myself.
I got stuff going on in my background, but yeah, it makes sense.
That's okay. So pose waypoint is the first button on the waypoint's nav bar and consists of a translation, and rotation. Drag the little yellow circle, okay, to change the heading of this thing right here. Yeah, that makes sense. Translation waypoint. Translation, it's nice that they have like docs. Translation waypoint is the second button on the waypoint's nav bar. Where's the waypoint's nav bar? Oh, right here. This is cool. Okay. It consists of a translation, but not a rotation. The UI still includes the yellow circle, but it's only stored to be able to convert later into a pose waypoint. Okay, so do you see what the difference is between the translation and the poses? Like, why is there not just all pose waypoints? Anybody? Because translation can lock the rotation. What does that mean? I think you're on the right track here.
Daddy,
What? Need a tissue? Right here. Can you try to go to sleep? Go sleep?
Yeah.
Thank you. So I think it's because basically at the end of the day, you're going to build a trajectory, right? You're going to build a path. But sometimes you don't really care about the path. You care about the robot being in certain places at some point in the trajectory. And so what this will do is you basically tell it what you care about, what you want, and then it'll like find the path that satisfies your criteria. So if you care about the angle of your robot, like for example for shooting, then then you use a pose waypoint. But if you just care that your robot is in this location, but you don't care what angle it is, then then you do a translation waypoint. A translation waypoint is less restrictive, and it allows the computer or the computate, the algorithm to basically like, be a little less strict. Okay. So I think, and then an empty waypoint, what is that? Empty waypoint allows you to apply a constraint somewhere along a segment without putting a position or heading constraint at that waypoint. What is what? Okay, I'm not sure. The initial guess waypoint. Yeah?
Adam, do you know why I didn't want to use Choreo over Path Planner?
Why you do?
But yeah, like,
Why?
what is like the biggest difference between the two programs?
Which? What?
The difference between Choreo and Path Planner.
What is the difference?
Oh,
Or
no,
are you?
I was asking.
I mean, at this point it's exploratory. I'm not sure which one we want to use. What I want to do is I want to bring up all of the options and then look at the options and then come to some sort of conclusion.
Okay.
That's what I'm doing here. Yeah. Okay. So what's a waypoint scope? Applies a constraint between. Okay. Segment waypoint is. Okay. So. Okay. Okay. Obstacles. Obstacles force the robot to avoid a certain area of the field throughout the path. For example, in 2023, you might want to avoid crashing into the charge station. That's a good idea. Obstacles make it easy to define where you want the robot to start and end without unnecessary intermediate waypoints. So, okay. So what this is saying here is you can define obstacles, which are like when the generator is trying to generate what the correct path should, or a valid path should be, it'll like avoid the obstacles. So that's cool. I kind of like this approach. This seems, I don't know, it kind of looks cool. You can create paths by chaining waypoints together. Okay. Okay. Generated paths. Okay. So this is all the GUI. And now in both if in both Path Planner, let me go back to here. In both Path Planner and Choreo, there's the GUI, which is like the visual. And then there is the code, like the library that you use to interact with these paths. Okay. So for Path Planner, it's called Path Planner lib. And for Choreo, it's called Choreo lib. Okay. But this doesn't give you any usage. Okay. So what is this? But then in here, so something about in here is I don't know how to like say at this position, the whole like events or the markers or whatever it's called. I don't really know how that works. Okay. I already did. Okay. Sorry. So it wasn't shut. Is that I don't know how to like set events. And also, I think we have sample code here. Maybe we'll just swerve with Path Planner. Okay, so we have sample code in here that works with Path Planner. So I think maybe we should go with Path Planner for now. Okay.
Okay.
Let's see how it works. Okay. So robot container, we'll see a lot of similarities. Does this look familiar?
Yeah, it looks a lot like the generated code.
Yep. So let's see. Okay. And drivetrain, blah, blah, blah. So same thing. Then they do that. Okay, forward straight. Yes, he is. He's sleeping. Okay, so they have this, which, okay, we don't have, but that's, whoa. Can you hear me?
Yeah.
Okay. Okay, so, so this is the first thing right here. So see path follower. So here's something that's related to Auton. What is this drivetrain thing? Drivetrain is that. Okay. So drivetrain. Command swerve drivetrain. Okay. What is that? So if I go into here and do drivetrain, dot get auto paths. Oh, wait a second. This drivetrain here, I think, comes from tuner constants drivetrain. Tuner constants from there. So I don't know what this thing is. Oh, command swerve drivetrain. Okay. Okay. So this right here is another file called command swerve drivetrain, and I think that does most of everything. So there's this line. I'm just looking for differences in the code. Then they do the telemetry, which we have here. Then they do configure binding. Is there anything special? This, nothing special. They have this ignoring disable, which we don't have. So let's look at what this is. Run or stop when disabled. I don't know what that's all about. Okay. Then they have like some buttons doing stuff, nothing important. This we have. You see this right here? This is while true. This is the button, the D-pad or whatever. Okay, fine. I don't think this is useful at all. Okay, so the only thing in here that's different is what? Is this, I think, right? Where's this run auto thing? Huh? I don't understand. Fine. So let's go into command swerve drivetrain.
Adam, I have to go, but thank you for this. This has taught me a lot. Thank you.
Mhm.
Bye.
Take care.
I have to go in about 10 minutes, but I could be here for that
Okay,
period.
sure. Command swerve drivetrain. Stand swerve. So something that's interesting is, see this command swerve drivetrain? This is called command swerve drivetrain here. Tuner constant. What's going on? Configure path planner. Okay, what does that do? Drivetrain radius is 0 for each of those. I see. Okay, got it. So what this is doing is it's getting the maximum, like the furthest module for swerve module. And here, this is saying autobuilder.configure holonomic. And then this is like the pose. Okay, it's a supplier which returns the pose. Okay, seating pose against auto. This is getting the current chassis speeds. Okay. Consumer of chassis. Okay. So this is a consumer of chassis speeds to drive the robot. Ah, I see. So this is very interesting. Does anybody know what this line is doing?
Just that line or what's under it?
This line is very important.
It looks like it's setting some speed of some kind.
Yeah, so, right, because basically the auto builder, right, that at the end of the day, it takes in a path, which I don't know how it actually knows which path to use. I'm not sure. But so basically auto builder, it let's see. It's basically what is it? Auto builder. See auto builder here?
Yeah.
It's basically what goes in is somehow a path goes in. And what comes out is like an array of wheel speeds where this array is over time. So like basically t equals 0, you know, wheel speeds, wheel speed 0. T equals 0.02, wheel speed 1. Right, because the path planner, at the end of the day, it gives you back what the robot should be doing at this time. That's how it works.
That makes sense. And auto builder just translates that into motor commands?
No, so auto builder is the thing which takes the path and outputs wheel speeds. But the thing is that now we have to, whenever there's a new wheel speed that is basically like output from auto builder, because auto builder, it's not going to give you just an array of wheel speeds. It's going to give you over time I don't know, let's say 10 seconds. Okay. Over time, it's going to give you a wheel speed here, a wheel speed here. It's going to give you wheel speeds at this time, at this time, at this time, right? So over time, it's going to give you wheel speeds. And now what you have to do is you have to send these wheel speeds to the actual drivetrain. Does that make sense?
Yeah. How do we
And
send
so
the wheel speeds?
So this right here, remember I don't know if you were here yesterday.
No, I wasn't.
No. So there's something called a supplier and a consumer. And a consumer basically is like listening, is able to be called by this configure holonomic thing inside of this code. It can basically, like when it has a new value, it can it can tell this consumer, hey, I have a new value. Okay, so basically this .set control is run set control is actually what sets the speeds of the wheels. And this is triggered whenever there's a new wheel speed. So this line is actually what gets the robot to do something. Does that make sense?
Yeah, that makes sense.
So this right here, new holonomic path follower config. I mean, we'll look into the docs in a minute, or I will, or whatever. But basically, the idea is that what this right here is doing is this is the target path at this position at this time. The target path, the ideal state of the system is that the robot is right here. Remember, ideal and where the robot actually is are two different things. So what you have to do is we've spoken about PID controllers.
Yeah.
Where the idea is that so this right here, this horizontal line is like the target, is the ideal. Let's say you're over here. This is where you actually are. And so a PID, what it does is it's a controller which says, okay, if I'm not where I need to be, how aggressively or in what manner should I get there? If you're at the target, that's fine. You don't have anything to do. You're perfect. You're following the path perfectly. But let's say something happened with the battery. The battery isn't charged fully. It's not going to achieve the the path that you want it to, for many different reasons. So this is why you're seeing a PID here. Okay, because if there's a difference between where you are right now and your target pose, this holonomic path follower config, like this PID here, is going to help you get there. And the reason why there's two is because with swerve, there's two things that can be off. There can be your translation, like where you are, like it wants you to be here and you're here. Okay, so then you have to get from here to here. And then also, there's a difference in the angle. You can be at a different angle than it wants you to be. So that's why there's going to be two. Okay. And I guess there's this constant here, drive base radius, which they did up here. And I'm not sure what this replanning config is. This right here, because the field is not symmetric in this game, if you're generating the paths on blue side, you can like apply like just a geometric translation to get it to, be correct on the red side. So this right here is going to be like, are we on the blue team or the red team alliance? Okay, so that's what this thing is doing. But yeah. I still don't get all of this generated here. Let's look at this. Because here's a command swerve drivetrain here. And if we go, so then here's a command swerve drivetrain. Command swerve drivetrain, import FRC robot. Oh, Mansword Dragon. Oh, interesting. I see how it's working. Okay. But what do we have? If I go into the generated, there is a command word drivetrain. FRC robot. Oh, we have one here. Oh, it's all. Oh, wait, the code is already here. Wait a second. We don't have to do much. Oh,
We just have to tweak some variables.
we just have to. Oh, by the way, I just got happier. I was like, oh,
No,
this is
no
gonna be a
writing code from
nightmare.
scratch.
This is gonna be a nightmare. You know what I can do? I can copy this code here. The power. Look, watch the power of Git. Okay. I can go into fork. I just copy and pasted the code. Mansword drivetrain. Git will tell me what the differences are. So what did they do? So okay, in order to get path planning to work, we need to import path planner. Okay, path planner, blah, 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 blah. We need to add the chassis speeds. Okay, tuner constants. Okay, fine. Okay, so what do we need to do? Inside of here, this is an auto request. Okay, apply chassis speeds. I got it. Okay, so when the command swerve drivetrain is initialized, we run the configure path planner. What that does is it goes through and it runs this function, which we just saw here. These variables we're probably going to have to tune. Okay. And then fine. Okay, so this is really, really, really good. This makes total sense now. Okay, I can sleep easier. Okay, the question I have now, first of all, let's go to Arc. I'm gonna head off in like 10 minutes, maybe. But we got somewhere, and I did not think we would. The first
I
thing we
actually
should
gotta
do.
go in like 1 minute.
Okay, that's fine. Take your time. Aaron, are you there?
I'm gonna stay here for like probably like 1 more
Yeah, I'm
minute,
here.
a little bit.
Cool. Okay, so are you following?
Yeah.
Okay, cool. So I really like this. Okay, so let's install this library because these are okay. So how do we install a library? Manage vendor libraries, install new libraries online, just like that. Yes.
Wait, so basically what you're doing is just bringing Path Planner into this thing like the other team did?
Yes, and it's just like whenever you have an external dependency, you go over here to manage vendor libraries. You go here, you'll see that we imported Path Planner, but also remember the Phoenix library, like to control the talons and all of the swerve stuff. We also had to import that. The way to import it, it's pretty cool how they designed it, is it's just what's called a JSON file. I don't know if you've heard of it. It's just a text file. Looks like this. And this right here tells tells VS Code where to find all of the code. Okay, so this is kind of like a configuration. So now it went away, and now we have all of the code imported.
And then on that note, I gotta go. Thank you for hosting this stuff. Will you be willing tomorrow, like after school? Or is that a little bit iffy.
After school is 4, that's not gonna work. What I will do is if we can get like an Auton mode working tonight, maybe we will, maybe we won't. I'll maybe go for half hour, maybe max. Um, then you can try an Auton mode. That'd be cool. I mean, we're not far off. We literally copied the code. So yeah.
All right. Thank you. Bye.
Yeah. Okay.
I'm sorry, but I need to go too. It's already 9.
Okay.
Thank you,
Great.
though. Bye.
Take care. Sure. Are you still there, or do you need to get going also?
No, I don't.
Okay. I'll be back in just 1 minute. Hold on. Back. So let's look at how this configure holonomic thing works. Actually, their docs do a pretty good job. Let's read the documentation in full. Path Planner lib AutoBuilder is used to create full autonomous routines based on auto files created in the GUI app. In order for AutoBuilder to be able to build these auto routines, it must be first configured to control your robot. Okay, so holonomic is what we're using because Remseti is for tank, and LTV I've never heard of. But holonomic is what we're using. Since all of the auto builder configuration is related to the drive subsystem, it's recommended to configure auto builder within your drive subsystem's constructor, which is what we're doing. Okay, the following example will assume that your drive subsystem has get pose, which it does, reset pose, get robot relative speed or get current speed, and drive robot relative or drive. Outputs command, okay. So let's look here. Oh, this is exactly the code. Oh, this is the max mod. Let's look at, is this helpful to understand what's going on?
Maybe. I'm also looking at the old path planner code that I was working on with just
Oh yeah,
for tank
I would
bot.
love to see it. Can you send me the link and I'll throw it up here?
I mean, I found a commented out version of that. But,
Sure.
yeah.
Yeah, send me the GitHub link.
This was.
Here, let's see. How did you do it? Okay, so Ramseti Auto Builder came from WPF. Wait, where's
Oh, yeah,
Ramseti
there's like
Auto
a.
Builder? Oh, from Path Planner. Got it.
Yeah.
So it seems like what happened a lot in the past, like this year. Well, okay, let's see. So get pose, reset odometry. I mean, this seems like it looks very okay.
Highlight the trajectory things, like how it gets, like what like path you're using from Path Planner.
Say that
So
again?
on like line 30, that's like where it gets the path that we're using. So I
Oh,
was
right here.
contacting bounds. Yeah, so it
Ah,
just
so you have
loads
to
the
do,
file.
I see.
Yeah.
Where do you have to save the file? Do you know?
Like on Pathfinder or in the code?
No, like in the code. Where is this found? Where do you find this?
I think this might be it's all you have to do is like put in the name of it, and it'll
Mhm.
like depending on what you title it in like Path Planner, it'll just know.
Okay.
I could be wrong. It's been a while.
Okay.
But I feel like
That's fine.
that's the only place where I could see like how like that would be called in the code. What's that line?
Yeah, let's look. Oh, load and auto right here. Okay, so in this year's version, creating an auto is as simple as constructing a path planner auto with the name of the auto you made in the GUI. Oh, I see. Okay, so what we're going to be doing here, so this is if you have a single, like a single Auton mode, right?
Mhm.
But here, we're going to have like multiple, right? So you have like you create a sendable chooser thing. After configuring the auto builder, you have the option to build a sendable chooser that's populated with every auto in the project. You just put that to the dashboard. And then here you just do get selected. That makes sense, right? Okay, so build an auto. The path planner live, auto builder is you. Okay. Wait, didn't we do this? Just did this. Named commands. Okay, so let's try this out. So here, this is, so inside of here, so what did they do? My question is the following. What did they do here? So this right here gets the auto path, and this is called in the robot container. That's called right here, get auto path tests. But where is this like scheduled? Do you know? Oh, here. Oh, I didn't even see that. Oh, that's convenient. Okay, so over here, get auto, that's easy. Return, dive train dot, get auto path tests. Okay, and then get autonomous command is just called in here, right? Right here.
Mhm.
Oh, sweet. Okay, so tests. So now, do we just have to go into Path Planner and name this like tests?
I think so, yeah. Oh.
Okay, is that it?
Feels like there should be more, but I don't remember there being more.
Because like, hold on. Telemetry. What is this telemetry thing? Is this to, this is how it works. Settings, localhost. Oh, it's not up yet. I see. So if I just go here and I like build the project. Oh. So it's going to connect to localhost, which is it just built it. I don't want to build it. Simulate. If this works, that's like super cool. Okay, so look at that. Okay, so now actual and commanded. Wow. Okay, so if I go to Auton, nice. I think my build auto. Oh, tests.auto is not found. Give me just 1 second. I'm going to take my son to the restroom. Hold on. I think we're almost there though.
That's good.
I don't know where. Here. Hold on. Meeting. I don't know what. Mm. Wait, hold on. Okay, maybe not. So you can still see my screen?
Yeah.
Okay, so we're close, but not there yet. So somehow tests.auto did not get saved. Path planner. Okay, so here, telemetry. Oh, what just happened? Okay, tests. Okay, telemetry. How do I know that it's saved? Okay, maybe I don't. Hold on. What just happened? Okay. So let's go back to Path Planner. We're super close, but it's like, how do we save it? Is the question. Path Planner GUI, telemetry. Okay. Getting started. Create a path. Adjust the settings to match your robot. Yeah. Path autos. Oh, was I creating a path but not an autumn? Oh, see, this is tests. This is a path. This is the auto.
Oh, interesting.
And I think this can like. Oh, this is what I wanted. But what's the difference? Starting pose, sequential group. Oh, follow path. Got it. This is what I was missing. This is what I was missing. So tests, okay? So these are like individual, okay, this is nice. So the autos, what this is like where you are building, like you have weights, you have blah, 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 you have all of this stuff here. Got it. So now if I go to telemetry and I go to here, I go to simulate robot code, it's gonna work. You ready? Are you ready for this?
Yeah.
Auton.
Yeah.
Did you just see that? Look at that. I
That was anticlimactic.
I thought I was, is there like a save? About path planner. Oh, what's this thing? Compact. No. Default folder.
Uh,
So why didn't it work? Oh, hold on. Main deploy path planner autos. So inside of deploy, yes, sir. User dot, okay, crescendo src main deploy. Well, that's the, oh, I see. Okay. So somehow it has to be put in this deploy.
How did the
That's how it works.
phone announce her? What did it say? Who's calling? Oh, okay.
Navigation. Okay. Oh, what about code projects? Maybe that's it. This whole project thing. Ah, you see
I
that?
watched it. I watched it.
That's how
I
it works.
used it earlier when I was starting to cook.
Here, look at
Yeah.
that.
I
Watch
was
this. So
rid
if I
of
do an
the
auto,
skipper and the frying pan and the little bowl for my wort salad. Just to make
we're gonna do a funky path here. That's cool, no? First pass. Tests. Edit. Sequential route. Follow path. First path. Starting pose. That. Go back. Tests. Nice. So now, hopefully, if I go into WPI lib, you see that? That was
Yeah.
the issue. So the issue was the project. This project is like actually the folder. And then this right here, these things are saved now inside of the deploy folder.
Yeah, it's like a JSON for it.
And so let's look. Okay, so whatever autos test
Yeah.
auto. You see that? And then this path here, you see these are the waypoints.
I think. Oh, never mind.
Yeah. Okay, so YOLO, right? When in doubt, YOLO. Auton. Whoa. Did you see that?
Yeah, it's doing it.
Okay.
When I was
Okay, so
doing,
we have.
uh,
Hmm?
when I was doing Path Planner with the tank bot, it was like really weird because I don't know. You had to like I don't know. It's also like extra stuff that you had to like micromanage to make sure everything is working properly. Like sometimes you could accidentally have it facing the wrong direction. And then like you'd have to do like extra steps and like just I'm gonna go completely crazy just to like even go like in a straight line sometimes if you get like slightly off, like everything messes up. Just cause like of the orientation it's like in because it's like tank bot you can't just like rotate 60 degrees as well. So that made
Yeah.
it really
I mean,
annoying.
there's that like the geometry that you have of the drivetrain that you have to respect, right? But
Hmm.
I'm not sure. Even with
Yeah,
the Ramsetti,
but yeah, sort of. I feel like at least just if you're like creating paths on the Pathfinder app, then it's just easy to make them,
yeah.
which is nice.
Okay, well now the Auton is like okay. So simulate. Hmm. Screenshot. Capture selected portion. Capture. Okay, hold on. Well, oops, no. Okay, so we're gonna record a video. Okay, so path planner. Let's do like, okay, we have that path. And we have an auto named test. Now we go here. Woohoo! That's just because we set the 0 there. Now we do upload, screen recording. Just make sure that's the right one. Yep. Oh, there's no sound. That's fine.
Oh my god, it's working. Um, I think I have to go now.
Yeah, I'm gonna head off now too. But we have path planning working.
Mm-hmm.
Um,
That's good.
yeah, I'd say so. Okay. Path planner work. First path planner trajectory working. Nice. Okay.
Thanks.
Quick question for you just before you go.
Mm-hmm.
Um, when Raylia pushed the code, she sorry, just really quickly. Robot container. She force pushed.
Mhm.
So that's not so good. The value, did he find a value that he likes already for this max speed? Was it 3?
Yeah, I
Or
think
does
it was. I think like when we were playing with the slider, I think it was like 4 maybe actually for the max speed, and then I think we kept the angling rate the same. Although I don't know if they like experimented more after I left.
okay, so I will we can just look at the code that was pushed, team 4 element view. Okay, crescendo new. The latest commit here is says 3. Well, that's the default value. Okay, fine. So I'll just copy this really quickly. Okay, sounds good.
Mhm.
I'll get this working. Okay, so good work.
Yeah.
Okay, take care.
Good night.
Good night.